Okay, so this is how I make my movies. So in the book, 14b looks at the angles between two lines and the intersecting line and the actual intersection points. I'm going to skip the first part. We're going to get back to that. First thing I want to talk about is finding the intersection. So finding the intersection of two lines. Okay, and now in this class, so we're in vectors. So it's going to be related to how we found the intersection of two lines. So first of all, let's start in two space. So in two space, either two vectors can be parallel or they can intersect. Now, later we're going to talk about the angle at which those two lines intersect. But first, I just want to figure out, do they intersect and where? Well, for parallel lines, in this class, we're going to look at the direction vectors. Of each line. And so if A equals KB, where let's say A is the direction vector of the first line, and B is the direction vector of the second line, if they're multiples of each other, we know that the lines are parallel. So there's no point in finding an intersection point. But if they're not, then there's an intersection point. And the question is, how are we going to find that intersection point? So I scroll to the book here. So let's take an example. The first line is equal to -2, 1 plus s, 3, 2. Now, you've noticed I used the letter s instead of lambda. These are just variables, so s is going to be our new parameter. And I might call this like line s. And let's call the second line rt, and let's call that 15, 5. And let's call the parameter t -4, 1. So just reviewing lines, the first line, it passes through -2, 1. There's no starting really. There's no ending or beginning. It passes through -2, 1 in the direction of 3, 2. And the second line passes through 15, 5 in the direction of -4, 1. Now, the next thing we need to think about is, the idea is we want the x's to be the same and the y's to be the same. Now we know that this actually is xy. It takes us to an x value and it takes us to a y value. So let me move my computer over a little bit. I could write this first part as x is equal to -2 plus 3s. In the first line, any y value is equal to 1 plus 2s. In the second line, same x and y, x is equal to 15 minus 4t, and the y value is equal to 5 plus t. Well, as I said before, we're looking to find where the x values are equal. So -2 plus 3s is equal to 15 minus 4t. And I also want to know where the y values are equal. So we can say that 1 plus 2s equals 5 plus t. Two equations, two unknowns. You know how to solve these. Let's just quickly do it. What we see is that, for example, this t is it's alone, so you're not going to write this as t is equal to 2s minus 4. Okay, so sorry, we have technical problems. That's why this seems weird. So t equals 2s minus 4. We're going to take the t and stick it in here. And so we get -2 plus 3s equals 15 minus 4 times 2s minus 4. We have -2 plus 3s equals 15 minus 8s plus 16. I'm going to move the 8s to the left. I have 11s. 15 plus 16 is 31. 33. S equals 3. Stick it back in here. We get t equals 2 times 3 minus 4, which is 2. A lot of algebra. It's just the idea, once again, the idea that the x's have to be the same, the y's have to be the same. math builds on each other. So you're going to find throughout your math career, it's a lot of the stuff over and over again, but it's in new levels. Take the t and the s, plug it in to see if it's correct. Let's look at the first line. R of s is equal to -2, 1, plus 3, the scalar 3 times 3 and 2, which is equal to -2 plus 9, 1 plus 6, 7, 7. Let's see if at the other time, when t is 2, the other line, when t is 2, if we get to the same points, it looks like it will. 15, 5 plus 2 times -4, 1. We have 15 minus 8 and 5 plus 2, and that gives us 7, 7. Something a little to think about. If we imagine this is time, and we're starting at our locations, then if these are our original locations and we're moving in these directions, it turns out although the lines drawn on the paper intersect, we don't get to it at the same time. So that's something we're going to need to think about. And I'm going to hold off on this until like a later unit. But I want you to imagine that, imagine that you're a secret spy or something, and you're walking along a path, and you just drop something on the ground, and you walk past, and at the same time, like someone comes in another direction at a different hour and like sees the thing that you dropped, picks it up, and walks away. Now your paths have crossed, you just haven't crossed at the same time. And as I said before, this is something we're going to explore in another chapter. Now, this is 2 space. We want to talk about 3 space. So the question is, we have 2 lines in 3 space. We've explored it, and you can go in GeoGebra. I'll show you in a second how we can do that. But the question is, what are the 3 options between 2 lines in 3 space? So 3 space. So we have 2 lines. So 2 lines, they're either parallel, they intersect, but there's a third option, and I'm just going to hold up my arms like this. Here's 2 lines in 3 space. They're not parallel, and they don't intersect. This is known as skew. The third option is something called skew. It's no intersection and no, not parallel. So this, for example, like you're looking at planes, you want 2 planes, they might be going different directions, you don't want them to crash, or you're doing warfare, you're sending rockets into space and maybe it misses. So the applications are endless, but once again, this is a math class. So first we want to get the math. So take a while to watch this video. I'm going to show you the point of the video. I'm going to show you a video of GeoGebra, and then we're going to come back and solve some math problems. Okay, so I just want to give you a visual of the next part. So the idea of the next part is we want to find the intersection of 2 lines in 3 space. So I'm going to create the lines in 3 space using GeoGebra, but using vectors. So the first thing I'm going to do is I'm going to input the point 0, 0, 0. I'm going to put the point -4, 1, 3, and I'm going to create the point 1, 1, 1, 4. Okay, because what I want to do is I want to create first. It's a little tedious. I want to first create the first vector to get me to A, to get me point B, and then I want to create the vector. So the equation of the line is -4, 1, 3 plus t, 1, 1, 4. So -4, 1, 3 is the first vector. It's going to be the point. 1, 1, 4 is going to be the direction vector. So I go to Tools, create a vector. The first vector is 1 to C, and I'm going to do 0A to B. Okay, and you can see that I have created the first point, -4, 1, 3, and I created the direction vector of the line that I want. And so I'm going to write that as R equals U plus T times V. And I got the line in 3 space. And let me just eliminate these two vectors. So I got this weird line. I got the line in 3 space, right? It's kind of cool. Next, let's put another line in. The next line is going to be, let me move my face out of the way, up here. Let's put the next line, let's see, the next line has the equation of S is equal to 2, 1, 1 plus lambda 2, negative 3, 2. So I'm going to put 2, 1, 1 to create the first vector. And then I'm going to put 2, negative 3, 2 to create the direction vector. Sorry. Enter. Next, let's create some vectors. So we're going to E and D. So let's go back to Tools, Vector. Let's see, A to E and A to D. There we go. Okay. Let's go back and let's create the line. Oh, because we have A and W are the vectors. And we have, let's call it S is equal to A plus T W. And nice. Now let's get rid of these two vectors. And with the second line. Now the question is, do these lines meet? Or are they parallel? No, we can clearly see they're parallel. And the question is, we can see that they're askew. They don't meet also, but we don't have technology. This might be a part 1 question. The question is, how are we going to do this? Well, I'm going to show you right now the technique. Now the green and the red are the like the X and Y axis, and that blue is the Z axis. So what we're going to do is we're going to assume that we can take a bird's eye view, and we're going to look straight down right here, and we're going to say, okay, I'm going to look directly, I'm going to project the two lines onto the XY axis. And it looks like they actually intersect at this point here. And that's the idea. So we're going to first find the intersection just with X and Y, and then we're going to algebraically plug it into Z and see if, let's see, no, I want the X. We're going to see if they actually meet, and we're going to determine if they meet or not. So once again, we're going to take a bird's eye view. We're going to see if they meet somewhere, and then we're going to see if so the video's over. Let's go back to the algebra. Okay, we're back. So let's find the intersection of two lines. How do we go about doing this? So the first equation is R equals 0, negative 4, 1, plus lambda 1, 2, 1. And the second line is, let's call it S, because I took it out of the book. The letters can change, but the idea is we have vectors, and this is our parameter. S is equal to 1, 3, 5 plus mu 4, negative 2, negative 2. Now, we're going to follow the technique that we discussed in the video, and that's we're going to assume that we don't know whether these lines intersect. Well, first of all, are they parallel? Are these lines parallel? Is S parallel to S? And the question clearly the answer is no. No, you can do it by inspection because 1 times 4 equals 4. 2 times 4 does not equal negative 2. And 1 times 4 does not equal negative 2. So we're good to go. It's not parallel. We could just say, there's no solution. Well, that's not the case. So once again, we're going to write out what we're going to do, like we saw in the video, is we're going to assume that looking down at the projection, that x and y do have an intersection point. So the first thing we're going to do is we're going to set x equal to 0 plus lambda, y is equal to -4 plus 2 lambda, and z is equal to 1 plus lambda. Then for the second line, we're going to look at 1 plus 4 mu, that's the other x. We have the other y is 3 minus 2 mu, and we have z is equal to 5 minus 2 mu. Now remember, we're going to assume that x and y meet at an intersection point. So we're going to just do it for the 2 dimension and see where x and y meet. There's a lambda and a mu that meet because once again you're looking down, and that's the intersection point. So let's see. We have 0 plus lambda equals 1 plus 4 mu, and we have -4 plus 2 lambda equals 3 minus 2 mu. Well, it's a book problem. It works out very nice. So what we're going to do is we're going to replace this lambda here and stick it over here. Once again, it's just a lot of tedious algebra, but let's go through this. So we have -4 plus 2 times 1 plus 4 mu is equal to 3 minus 2 mu, right? We have -4 plus 2 plus 8 mu is equal to 3 minus 2 mu. Nice, this is 10 mu. Let's see, we have 3. Did I make a mistake somewhere? No, perfect. -2 becomes 3 plus 2 is 5. Mu is equal to 1/2 or 0.5. We'll decide, it's up to you, but I'm assuming this is probably going to be a calculated problem. So let's see. If mu is 1/2, that means lambda is 1 plus 4 times 1/2, which is 3. Okay, so we assume that we have an intersection point. We know that if we get mu, if we put the lambda, let's see, so let's plug it back in. So let's take r. I'll do it right here. When lambda is 3, r is equal to 0 plus 3, -4 plus 3 times 2. And I'm going to leave this blank for a second. So it ends up being 3 and -4 is 2. Let's hold off on the z for a second. Let's look at the s. So with s, the parameter is mu, and we have 1/2. I'm going to use 1/2 because it's all even numbers, so it's easy. So let's see, x is equal to 1 plus 2, which gives me my 3. Nice. Let's see, we have 3 minus 1, right? Because 1/2 of -2 is -1 plus 3. I give you my 2. Now the thing is, here's the last part. You have to plug in the lambda and the mu for the respective z values. If the z values are equal, then the lines intersect. If the z points are not equal, it turns out that the line that we thought was was intersecting, actually it turns out it was skew. Let's see what's going on here. Well, let me use a different color. Let's use blue. We have 1 plus 3, which is 4, and we have 5 minus 1, which is 4. Nice. Because the z values are equal, because zr is equal to zs, the lines intersect at 2, 3, 2, 4. Nice. Let's try another one together. You can speed it up. I'm going to do the arithmetic with you. Now I'm telling you the next one is skew. You can see the GeoGebra, but you have to be very careful about this. So let's see. Let's see what's going on. The next one is R is equal to -413 plus T, which is 114, and S, which is equal to 211 plus lambda times 2 -3 2. Remember, first of all, are these parallel? Is R parallel to S? Just by inspection and knowing that obviously IB is not going to give away the chance to make you do a lot of algebra. No. So clearly 1 times 2, 1 times 2, no. 4 times 3, no. These are not parallel. No, really no. Because the direction vectors are not multiples of each other. Okay, well, let's get to work. Well, we've lots of ones here, so we know that the algebra is going to be easy. Let's compare the x, this is xyz, xyz. Let's get some equations together. So we know that -4 plus t is equal to 2 plus 2. You know what? I'm going to change this to like v, just to make our lives easier. And let's do 1 plus t is equal to 1 minus 3v. You can either set these equal to each other or you can subtract them off, because I can easily eliminate the t's. So let's see, -4 minus 1 is -5, t minus t is 0, 2 minus 1 is 1, and 2 minus -3 is positive 5v. So I have 5v is equal to -6. V equals -6/5, or -1.2. -1.2. Now let's figure out what the t is. Can you see down there? Yeah. Let's see, what do we have here? -4 plus t is equal to 2 plus 2 times -1.4. We have t is equal to 6 plus -2.4. T is equal to 3.6. Okay, that's not so bad. Let's see. First of all, I want to see if I did my arithmetic correctly. So let's see. T is 3.6. Let's see. We have -4 plus 3.6, which is, what is that? That's -0.4. Let's see, 1 plus 3.6 is 4.6. What's going on with the z? We have 3 plus 4 times 3.6, which is 14.4, right? 36, 72. No, I apologize. Let's see, it's 4 plus 4 times 3.6. 17.4. Okay, let's see. Nice. Let's see what's going on here for S. For S, we have 2 plus -1.2 times 2. So that's -2.4 minus 2. That gives me my -0.4. Nice. Let's see what's going on with the y's. We have 1 plus -1.2 times -3, which is 3.6, 4.6. Nice. Now let's see if this last part equals 17.4. And we have 1 plus 3.6 times 2, which is 72, which is 8.2. No. So they're skew, because ZR does not equal ZS. Now, Yeah, it's long, it's algebra. Yeah, but you gotta do it. Good luck.